Hello, dear students. We are studying our mathematics paper 1, linear algebra of semester 4. We have already started unit number 1, matrices and system of linear equation. Now this is our lecture number 2, and in this lecture we are going to see system of linear equations and we will see consistency of system of linear equation. So let us see system of linear equation. Let us consider a system of m linear equations in n unknowns. So very first equation is a11x1 plus a12x2 plus etc. a11xn equal to b1. Second equation will be a21x1 a22x2 plus etc. a2n equal to b2 etc. m linear equation is am1x1 plus am2x2 plus etc. amn xn is equal to bm. So how many equations? This is first, second, third, etc. Total m number of equations and unknowns. So this is x1 is unknown, x2 is unknown, x3 is unknown, etc. xn. So total n unknowns are there. So this is the system of m linear equation in n unknowns. You may call this as system 1. If at least one bi is non-zero, if at least one bi is non-zero means if at least one of RHS constant is non-zero, then this system is called non-homogeneous system of linear equation in n unknowns. Unknowns are also called as variables x1, x2, etc. xn. And if all bi's are 0, means if all RHS constant are 0, then the system is called homogeneous system of linear equation. So remember, if all RHS constant are 0, then system is homogeneous. If at least one RHS constant is non-zero, your system will be non-homogeneous system of linear equation. The matrix form of this system is given by Ax equal to B. So this A is matrix, X is matrix, B is matrix. Where? What is this capital A? Capital A is coefficient matrix, and you just have to collect all coefficients. So in first equation, coefficients are A11, A12, etc. A1n, that will be the first row of your coefficient matrix. Then go to the coefficient of second equation, so A21, A22, etc. A2n. So that will be your second row of your coefficient matrix, etc. The coefficients in m equation are am1, am2, etc. amn. So this is your mth row of coefficient matrix, and now this coefficient matrix is always denoted by capital A. Then what is X? X is matrix of unknowns or matrix of variables. So x1, x2, etc. xn. So total n rows are there, but only one column. And the matrix B is column matrix of RHS constant. So B1, B2, etc. Bn. So what is the order of this matrix? So this is m by 1. What is the order of this matrix? This is n by 1. So what is the matrix order of this coefficient matrix? So this is m by n. So remember, m by n will be the order of matrix of coefficient, then X is the matrix of unknowns, and B is the column matrix of RHS constant. The Augmented matrix of system 1 is denoted by square bracket capital A comma B, or square matrix capital A, vertical line capital B. So this is the notation for augmented matrix. And how to obtain this matrix? This matrix obtained by joining column matrix of RHS constant to the matrix of coefficient. So up to this is your coefficient matrix, and if you join one column, which column? Column matrix of RHS constant, then matrix obtained is called augmented matrix. Now what will be the order of this augmented matrix? So m number of rows are there, just we are joining one column, so the number of columns will be n plus 1. So order of this matrix is m by n plus 1, and this is augmented matrix. So remember, augmented matrix is obtained by joining RHS constant to the coefficient matrix. Let us see consistency of system of linear equation. So system of linear equation is said to be consistent if it has at least one solution, and if system does not have any solution, then that system is said to be inconsistent. Now we are going to condition for consistency of system of linear equation. So system of linear equation is consistent if condition is that rank of coefficient matrix is equal to the rank of augmented matrix. That is, system of linear equation, we have already stated, is consistent if rank A is equal to rank of A augmented B, and if this is not equal, then in that case you can say that given system is inconsistent. Means given system of linear equation will have at least one solution if rank of coefficient matrix is equal to rank of augmented matrix. This is for non-homogeneous system, and for homogeneous system is always consistent, because zero solution is always a solution of any homogeneous system. In fact, this condition, rank of coefficient matrix is equal to rank of augmented matrix, always hold, because if you join any number of column to the matrix, then that doesn't affect on the rank of matrix. So rank of A is equal to rank of A comma this O. O stands for column matrix containing all zeros. So remember, homogeneous system is always consistent, means the system always has a solution. So zero solution is always a solution of homogeneous system. And for non-homogeneous system, condition for consistency is that rank of A is equal to rank of A augmented B. In the next lecture, we'll see how to find solution of given equation. Before that, let us see type of solution. So for non-homogeneous system, so non-homogeneous system of M equation in n unknowns is denoted by Ax equal to B. Now here, if rank A is equal to rank of A augmented B, and if that equal to n, what is small n? N is number of variables, then the given system has unique solution. Unique means only one solution. So for unique solution, your rank of A equal to rank of A augmented B, and that equal to number of variables. And if these two ranks are equal, but that is strictly less than number of variables, then your conclusion is that system has infinitely many solutions. So for infinite number of solution, your rank must be less than number of variables. And if rank A is not equal to rank of A augmented B, then you conclude that system has no solution, means your system is inconsistent. So remember three types of solution. unique solution, infinitely many solution, no solution. For unique and infinitely many solution, your rank of A must be equal to rank of A augmented B. And if this common rank is equal to number of variables, then system has only one solution. And if this common rank is strictly less than number of variables, then your system has infinitely many solutions. So this is for non-homogeneous system. Let us see for homogeneous system. Homogeneous system is denoted by AX is equal to capital O. So that O stands for column matrix of RHS constant, and in fact that RHS constants are all zeros in the case of homogeneous system. So here rank A is equal to rank of A comma O always hold, and therefore system of homogeneous system is always consistent and zero solution is always a solution. Now there only two conditions remains. We have to check whether the rank of A is equal to number of variables or less than number of variables. If rank is equal to number of variables, then system has unique solution, means only one solution, and only one solution means your trivial solution. Zero solution means all variables are zero, in which case rank is equal to number of variables. And if rank is strictly less than number of variables, in that case system has infinitely many solution, means your homogeneous system has non-trivial solution or non-zero solution. So for non-trivial solution, your rank must be strictly less than number of variables, and for trivial solution, your rank is equal to number of variables. So this is about homogeneous system. In the next lecture, we are going to see examples on system of linear equation. In that case, we will see homogeneous and non-homogeneous system simultaneously, because there is no separate method for homogeneous and non-homogeneous method. So here we will stop. Thank you.